and welcome to the Chemistry channel. So this video is going to be introducing aqueous solutions. So what is a solution? A solution is a homogeneous mixture of two or more substances. So solutions can be made up of solids, solid and solid mixed together. That's usually called a metal alloy. So a great example of a solid solution is a metal alloy. You can have two liquids mixed together or two gases. They just have to be a homogeneous mixture. So solutions are generally made up of two different parts. The first part is called the solvent. And the solvent is the substance present in a greater quantity. And then the second part is called the solute. And the solute is the substance that is dissolved in the solvent. Now in Gen Chem, H2O, or water, is usually the solvent, and these types of solutions are called aqueous solutions. So an aqueous solution is a solution that contains water. So it's a solution that contains water. And when you're talking about aqueous solutions in general chemistry, water is usually the solvent. So let's get more into solutes. So solutes can be classified in two general categories. The first category are called electrolytes, or the electrolyte category. So electrolyte. And an electrolyte is a substance that ionizes in solution. So what does ionize mean? Well, ionize means that the substance basically dissociates. So for example, if you had sodium chloride in water, if you put that in water, you would form two dissociated ions, a sodium ion and a chloride ion. So this is what it means to ionize in solution. And in fact, substances that ionize in solution are called electrolytes because when they are in solution, they can actually carry an electric current. So that's why they're called electrolytes. So the second group are called non-electrolytes. So a non-electrolyte is a substance that does not ionize in solution. So this means solution. So as an example for both of these, electrolyte, one example of an electrolyte is sodium chloride. Another one would be hydrochloric acid, sulfuric acid, etc. So electrolytes tend to be ionic compounds that are soluble in aqueous solutions, along with the 7 strong acids, which we will go over. And then non-electrolytes, a non-electrolyte would be something like glucose. So this would not carry an electric current and would not ionize in solution. So electrolytes can be further subdivided into two different categories. So electrolytes can be further subdivided into two different categories. The first category are the strong electrolytes. And strong electrolytes are electrolytes that completely ionize in solution. So once again, a great example would be sodium chloride. So for a chemical equation showing a strong electrolyte, it would be represented as such. So for example, you would have NaCl in your solid form, and when you dissolve that in H2O, when you dissolve that in H2O, it would form sodium ions and chloride ions along with your H2O in there. So this would be an example of a chemical equation showing a strong electrolyte. And note, I only put the water in here to show you that it's dissolved in water. If you were to see this in a general chemistry textbook, you would not have the water in the equation. You would just have the sodium chloride and then the two ions. So other examples of strong electrolytes are these strong acids. And we will get into some strong electrolytes in future videos. So the second type of electrolyte is called a weak electrolyte. And a weak electrolyte is an electrolyte that does not completely ionize in solution. Instead, it attains an equilibrium. So an example of a weak electrolyte is acetic acid. So this is acetic acid. And how you would show a weak electrolyte is you would use this equilibrium arrow. So this is an equilibrium arrow. And on the other side, you would put your anion, so acetate, and your hydronium ion. So what is this equilibrium arrow telling us? Well, this equilibrium arrow is telling us that the rate of the forward reaction is equal to the rate of the reverse. So in other words, the rate of dissociation of acetic acid is equal to the rate of formation of acetic acid. So this is just a little taste of what a weak electrolyte is. So we're going to get more into equilibrium once we get more into thermochemistry and thermodynamics. So the last little topic I have for today is the process of dissolution. So a general idea of what dissolution is. So dissolution is the process of a solute dissolving in the solvent. So in order to show this process here, I have a little figure. So this little square, this little rectangle, is sodium chloride. So this is like a block of salt that's super magnified so that you can see the individual ions. So the red little circles are sodium ions, and the white little circles are chloride ions. So let's just say you put this little sodium chloride block in water. And you put it in a little beaker of water. And let's magnify what water looks like. So this is the Lewis structure. So this is the Lewis structure of water. And we're going to get into Lewis structures in a later video. So this is what the structure of water looks like. And what you need to know is that water is polar. It is polar. So polar or polarity basically tells us that there is a partial positive end and a partial negative end. We're going to get more into polarity once we talk about electronegativity in a future video. So water is polar. So what happens is that in this bond here, this bond is made up of two different electrons. So this bond here, this is called a covalent bond. So covalent bond. And this covalent bond is formed by two different electrons. And these two electrons are shared between the hydrogen and the oxygens. So the only thing that you need to know now is that oxygen wants these electrons more than hydrogen. So oxygen keeps these electrons closer to itself than hydrogen. So therefore, oxygen has a partial negative charge, so this means a partial negative charge, and the hydrogens have a partial positive charge. So this is what the charges are on water. And once again, we're going to get more into why this is in a later video. So let's now magnify what sodium chloride looks like by focusing on only two ions. So here we have our sodium ion, and the white circle is the chloride ion. And now note that these three orange lines here indicate an ionic bond. So an ionic bond. And here is the chloride ion and the sodium ion. So these two little ions are connected to each other by this ionic bond, which is an electrostatic force. However, when you put this sodium chloride block in water, the water molecules actually start to pull on these two different ions. So which part of the water molecule do you think will be attracted to the sodium ion? The oxygen or the hydrogen? Hopefully you said the oxygen. And it's the oxygen because the oxygen has a partial negative charge. Opposite charges attract, so therefore the oxygen forms an interaction with the sodium ion. And then, since you're in a whole beaker of water, you have a ton of water molecules interacting with this sodium. And you have a ton of different interactions which pull the sodium ion away from this ionic bond. So you have this force pulling the sodium ion away from the chloride. Now, the water molecule also attacks the chloride ion. So which part of the water molecule do you think will attack the chloride? Hopefully you said the hydrogen, and that's because the hydrogen has a partial positive charge. So you have this partial positive charge pulling on this chloride ion, and it's pulling this chloride ion away from the sodium ion. So you have all these waters pulling the chloride ion away from the ionic bond. Now eventually, this causes the two to separate. So the two different ions separate from each other. And what happens is the water molecules orient themselves around each ion. So the oxygens will orient themselves around the sodium ion. And that's because, once again, the oxygens have a partial negative charge, while the hydrogens of water will orient themselves around the chloride ion. And that's because they have a partial positive charge. So I'm only going to write partial positive on one of them. And note that this process is called solvation. And solvation is the process of the solvent surrounding the solute, preventing it from coming back together. Because look at this here. Now you have all these water molecules surrounding the two ions. Now, since the water molecules are surrounding the two ions, the water molecules sort of form a protective barrier around each of the ions. And this protective barrier keeps the ions from coming back together again. Therefore, the ions are free to float around in the solution. So that is why when you write the process of dissolving sodium chloride in solution, you you dissociate both of the ions away from each other. Because the water surrounds itself around each of the ions, sorry about that, that should be a chloride. So the water surrounds itself around each of the ions, causing them to separate from each other, keeping them from coming back together. So that is the process of solvation. And that ends the material for today. I want to thank you all for watching this video, and I hope I helped you understand the material a little bit better. And in the next video, we're going to carry on with our discussion on aqueous solutions. So I want to thank you all for watching, and I hope to see you next time. Thanks everyone.